Hi, my name is Shivam, and me and my fellow groupmates, will present you our work on key value columnar database and Docker. A key value database is a form of non-relational database that stores data using the straightforward key value technique. In a key value database, each key value pair contains a unique identifier that is used to store data. From fundamental objects to intricate composite items, both keys and values are open to interpretation. Key values database may scale horizontally to scale the other database formats, are unable to accomplish, and are highly partitionable. If an existing partition is full, an extra storage space is needed. For instance, Amazon DynamoDB assigns additional partitions to a table. Now let's talk about some use cases. First is session store. An application that is session oriented may contain user profiles, messages, personalized data in themes, recommendations, targeted advertisements, and discounts. Here, session data is better suited for a quick key value store. Shopping cart. An e-commerce website may receive billions of orders in a single second during the holiday shopping season. Additionally, key value databases feature built-in redundancy, which can grow massive volumes of data and handle the loss of storage nodes. Now let's talk about example of key value databases. Key value database is a type of NoSQL database. Implements a hash table to store unique keys along with the pointers to the corresponding data values. Scalar data types like integers or complicated structures like JSON, list, BLOBs, and other sorts of data can be used as a values. Key value stores have no query language, but they do provide a way to add and remove key value pairs. On the right hand side, we can see an example of a simple key value data store. In the phone directory, we can see that key are the name of a person like Paul, Greg, Marco, and the values are their corresponding phone numbers. Now let's talk about feature of key value database. A key value database is one that enables applications to retrieve data using keys, which are effectively names or identifiers that point to some stored value. There is no comprehensive list of characteristics, but there are few frequent ones because the key value databases are defined so simply yet can be extended and optimized in a variety of following ways. First, retrieving a value if there is one stored and associated with a given key. Second, deleting the value if there is one stored and associated with a given key. And third, setting, updating, and updating the value if there is one associated with a given key.
Hi, I'm Charita, and in this slide, we will be talking about advantages of key value databases. Simplicity. It is easy to use key value database. Programmers' jobs are made simpler by simple commands and lack of data kinds. Data can be taken on any type, even number numerous kinds as necessary, thanks to this functionality. Now, coming to speed, key value databases are quick to respond because because of their simplicity. Assuming the rest of the environment is well built and optimized. Scalability. It is widely acknowledged that NoSQL databases have the benefit over relational databases in general and key value stores in particular. Key value stores. Now coming to simple to move, since there is no query language, the database can be simply transferred between platforms without altering the design. Reliability. Built-in redundancy is useful to replace lost data with duplicates data in the event of lost storage node. In this slide, we will be talking about the disadvantages of key value databases. Simplicity. The list of positive, negative shows that everything is relative, and that is what they typically consider to be advantages can occasionally turn out to be a drawback. This serves as another evidence that uh, you must thoroughly analyze your need and available options for before selecting a database to employ key value store and not sophisticated because they lack completely. The key is the only way to query the database. Neither a language nor any easy method exists to use something else. Lack of query language. Without a common query language, it may be impossible to transfer queries from one key value database to another. Values can be filtered. The database cannot understand contents of values since it perceives them as blobs, whole values rather than a specific piece of information are returned in response to a request. and when they need to be modified, the entire value must be updated. In this slide, we'll talk about popular key value databases. REDIS, a multi-purpose database that acts as memory cache and memory broker. Amazon DynamoDB, probably the most widely used key value store database. In fact, it was the research in DynamoDB that really started making NoSQL really popular. Couchbase interestingly allows for text searches and SQL style querying. Aerospike, open source database, this is optimized for in-memory storage. Memcache helps speed up website by storing cache data in RAM, plus it's free and open source.
Hi, I'm Romana. I will be going through the introduction to Columnar database now. So what is Columnar database? It is nothing but a data that is stored in columns rather than rows in a database management system that we basically refer to as DBMS, and this is called Columnar database. The purpose of a columnar database is to efficiently write and read data to and from hard disk in order to speed up the processing and response to a query. Columnar databases are used to store data, which greatly improves the speed of disk input-output. For analytics and data warehousing, they are particularly helpful. Now, let us compare columnar with the row database. Let us start with how the data is stored in these two databases. Row-wise and sequential data storage is the norm for traditional databases. To keep track of all employees in a company, for instance, records might be arranged in a row with ID 1, name, and department being recorded. This is followed by a new row that contains all of the information for ID 2. There are no neighboring data that are identical. Accessing data from storage disks takes longer in this case. In contrary, a columnar database displays each employee's name in a row or immediately next to another. Each name in the name column is followed by a department name in the department column. Due to the fact that the entire column's data is gathered and saved at once, this makes the process of obtaining related information simpler. Next, let us compare these two databases based on their performance. Columnar databases scalable to increase throughput using distributed clusters of cheap hardware. The ideal solution for use cases like financial transaction is to store millions of rows of data in a relational database. However, because it is built for speedy retrieval of data in columns, columnar storage excels at performing data analytics jobs. Improved query performance results from reduced overall disk input-output requirements. Due to the uniform nature of the data in a single column, column-based data storage supports better compression, which lowers input-output overhead by cramming more column values into each data page. In fact, compressed columns can often be completely cached in memory, resulting in blazingly fast query speed. Now let us take a look at some of the benefits of using columnar database. It is multi-purpose. Columnar databases are increasingly popular in huge data applications. They are used, among other things, to operate OLAP cubes, store metadata, and do real-time analytics. Columnar databases work well for these users because of how quickly fresh data can be loaded into them. Data that a columnar database may compress heavily is said to be compressible. Columnar operations like min, max, sum, count, and average can be finished quickly because of the compression. Self-indexing. Another advantage of a column-based BMS over an RDBMS is that it requires less disk space to store the same amount of data. And next, efficiency and speed. Columnar databases handle analytical queries more quickly than other database technologies. Additionally, they function fast and efficiently when connecting data from two tables in a relational database. Despite being a common method for integrating data, a join can be inefficient and slow. A columnar database may quickly link any number of data types and combine the response of several queries into a single output. Now let us look at some of the popular columnar databases. OLAP queries on massive datasets can be executed more quickly with Apache Druid, an open source real-time analytics database. Real-time ingestion, like up to millions of records per second, quick query performance, and high uptime are crucial requirements for Apache Druid. Apache HBase is an open source distributed column-oriented NoSQL database that runs on Apache Hadoop framework. A column-oriented non-relational database called Apache HBase is built on top of the Hadoop distributed file system. An open source distributed data storage engine called Apache Kudu is used to do quick analysis on constantly changing data. Column-based storage offered by Apache Kudu enables effective compression and encoding. The storage model of MonetDB is based on vertical fragmentation. Its software architecture is modular and its query execution architecture is optimized for current processors. ClickHouse. ClickHouse is a quick and simple to use open source OLAP database management system. Because it is column oriented, it enables the instantaneous creation of analytical reports using SQL queries. Using a parallel distributed data architecture, MariaDB Column Store is an open source column-based storage engine that is intended for processing petabytes of data. MariaDB provides great performance with real-time responses to analytical queries and is linearly scalable.
Docker is an open source platform that enables developers to build, deploy, run, update, and manage containers. Standardized executable components that combine application source code with an operating system, libraries, and dependencies required to run that code up in a given environment like Linux, Windows, and Mac computers. This enables the application to run away in variety of locations such as on-premises, in public or private cloud. When running on Linux, Docker uses the resource isolation features of the Linux kernel and a union-capable file system such as overlay fs to allow containers to run within a single Linux instance. Now, let's talk about containers. A container is a standard unit of apps that bundle commands and data and all its dependencies so that the application can be moved from one computing environment to another quickly and reliably. A Docker container image is a lightweight, standalone, executable package of software that includes everything needed to run an application code, runtime, system tools, system libraries, and settings. There are different types of containers that can be marked up and followed in a given manner, standard and lightweight. Standards. Docker created the industry standard for containers so they could be portable anywhere. Secure. Applications are safer in containers, and Docker provides the strongest default isolation capabilities in the industry. Here we can see a brief description about containers and virtual machines. Now let's talk about Docker volumes. Containers frequently need to access data outside of their bucket or share data among containers. While it can be tempting to depend on present a file system while working with a data structure in a carton, specifically Docker volumes is a better alternative. Docker volumes are file systems mounted on Docker containers to preserve data generated by running container. Docker volumes are a file scheme and a favored method for storing data for Docker containers and assistants. Docker loads the learn image layer, adds a notice layer to the top of the image file, and known as mount quantities on a vessel file system when a container is started. The volumes are stored on the host independent of the container lifecycle This allows users to back up data and share file systems between containers easily. Advantages of using Docker over bind mounts. Bind mounts also work in the same manner, but there are more advantages when it comes to the volumes. Let's see them. Volumes are easier to backup or migrate than bind mounts. You can manage volumes using Docker CLI commands or Docker API. Volumes work on both Linux and Windows containers. Volumes can be more safely shared among multiple containers. Volume drivers lets you store volumes on remote hosts or cloud providers to encrypt the content of volumes or to add other functionality.
Hi, my name is Rohan Bhatt, and now I'll be talking about volumes. So basically, these are the volumes that are get worked upon the Docker system. And now let's move on to other slide. So here are the Docker volume commands to it. So as we said, the Docker volumes is nothing but the data sets or the databases or that would be run over the Docker system. So to connect with it, there are some of the commands that Docker volumes uses, and here are the commands like -v source destination options docker run time, and all these are the commands for Docker volumes to be created and how and to be worked upon it. So this is how it is looked like. Here we created the Docker volume. Over here we can give the volume name, and these are the local that shows that it's on a particular system of that particular window, or maybe we can say the PPT presentation. Okay, so now I'll be talking about Docker networks. So when it comes to Docker networks, first of all, we need to know that Docker services is such a powerful thing that it can get connected with Docker as well as non-Docker workloads. Docker containers and services are not required to be aware that they are running on Dockers. So the best part is that you can connect it with Docker workloads that don't even know whether you are working on Dockers or not. For Docker containers to communicate with each other and the outside world via the host machine. So mainly the Docker containers communicate with each other via the host machines. Docker supports different types of networks, each fit for certain use cases. That's what the Docker networks talks about, that each Docker supports has a different type of network to it. So here is the single host thing, whereas we have one container, Docker container, having the instance one in it, and it has been worked upon BR1, that means any system, and it is being working upon it. On the other hand, there is another instance too, which is another container of Docker, but these are not connected with each other. But we can even connect these guys with each other to make a Docker network out of it. So mainly the part of this whole presentation is to clear about the fact that networks are the most crucial part of Docker, and it holds an important aspect of making the process more lenient. Types of different networks. So now I'll be talking about the different types of Docker networks, and over here we have mainly took only one bridge network, that is the most crucial one. So like on an average there are more than three different types of networks, but here we'll be only talking about the bridge networks. So the bridge network is the most common network type. Bridge networks are easy to create and manage, and the problems like the troubleshoot problems are easily accessible with them. The Docker Bridge driver automatically installs rules in the host machine so that containers on different bridge networks cannot communicate directly with each other. When you start a Docker, a default bridge network is created automatically, and newly started containers connect to it unless otherwise stated. That means whenever you connect the Dockers with a Docker volume, or whenever you connect a bridge with a Docker network, it's gonna get connected very easily, and when you start it, it's going to be an automatic process to it. Overlay networks. Now over here I'll be talking about the overlay networks. So the overlay network driver creates a distributed network among multiple Docker daemons hosts. That means that the overlay network drivers are distributedly connected with each other, and they are working for a single Docker host. This network sits on top of the host specific networks. That means there are a few specific networks or maybe a single specific networks over which these networks work upon. Like they are connected with the Docker volume and all this stuff, allowing containers connected to it to communicate securely when encryption is enabled. The Docker transparently handles routing of each packet to and from the correct Docker daemon host and the correct destination container. Lastly, I would like to say thanks. This was all of the PPT on our Dockers and all of the columnar databases that we have used upon it. So thank you so much, and thank you, Tim, for helping us out and giving us this opportunity to make such a beautiful PPT on a very unique and a new topic, that is of Docker. And thanks to all my team members for putting in so much hard work on making this whole presentation. Thank you so much.